Okay, I had to go. Hey y'all. I had to go to what is that called? The screencasting so I could make a copy of this because Ms. Mixon always forget to do all this stuff. Hello, pumpkin pies. How are y'all? I'm doing good. Don't forget that we have to, what is it? Y'all got a Zoom meeting at 3 o'clock. So I'm going to end about 2:55 so that everybody can go log in. Okay, go at 2:55. Make sure you go to your feed so you can see where the Zoom meeting is. Okay, just want to make sure that everybody logs in for the Zoom meeting. Okay, so here are the problems we're going to do. All right, so it is week 4, day 2. Okay, week 4, day 2. All right. So you remember I said we're going to solve the problems. It goes 1, 2, 3, 4, 5, and then somebody couldn't count because they went back to 4. I guess they just got real confused like Miss Mixon, but it's all good in my neighborhood. All right. All right, so let's get started. My one little person that's with me. All right, here we go. Okay, so it says for 1 to 3, calculate the area of each triangle. Each figure is not drawn to scale. Okay, so exactly, it is you, Miss Martin. You are the only person that is in my life. So hi, how are you? Let me know if you want to join me so I can talk to you. Anywho, so remember the formula for finding the area of the triangle is 1/2 base times height, or base times height divided by 2. I usually set mine up this way because I just find it's easier for me to do. Okay? But either one is correct. So let's find out what we're doing. All right? Here we go. So let me turn. Hello, other adult. You're the only 2 people that are in my life are 2 adults. So hello. All right. So let's look at our first triangle. All right. Let's find the base, which is 8 feet. And remember, these aren't drawn to scale because this isn't really an 8 foot drawing. Okay. So the kids just sign in and jump out. That's life. All right, the base is 8 feet and the height is 15 feet. Okay, remember from your lesson on, I guess that was yesterday, right? About finding the height of the triangles. Okay, remember that? All right. So let's do our base. So our base is 15 times our height. I'm sorry. See, y'all have me messed up because I'm looking at y'all love. That is so nice. Or the base is 8 feet times the height is 15 feet. And then we're going to divide that by 2. Okay? All right. And you remember y'all did this problem on, I guess that was Wednesday. I just wanted to make sure that we reviewed it. Okay, so we multiply 8 times 15 and we get 120. Divide that by 2 and we get 60. And remember, we're talking about area, feet times feet, and it'd be feet squared. 60 feet squared. All right. Excellent. All right. I did a fabulous job. Yay me. Okay. So let's do the next one. Now, sometimes they try to trick you with the way the triangles go, and you can just, go and turn your paper around. It's fine. See that I turned my paper around, and then it makes it much easier for me to handle. So the base is the distance at the bottom, and that's 6 inches. And the height, remember the height? 8 inches. Okay? The height is 8 inches. See that? Okay. The height is 8. The base is 6. So what do I have to do? Multiply my base, 6 inches, times my height, 8 inches. All right, so let's do that. Make sure I'm looking at my formula, and I make myself little notes. B equals 6, H equals 8. Look at that. See that? I made myself a little model. Yay me. So it's 1/2 of the base times the height. Or another way I could write it is, base times height over 2. Either one of those ways is correct. I find it's easier for me to multiply and then divide, but that's just my own personal preference. So then I get 48, because 6 times 8 is 48, okay? And 48 divided by 2. And I look at my unit, inches times inches is inches squared, okay? So 6 times 8 is 48 divided by 2 is 24. And we have 24 inches squared. Yay! All right. Okay, let's look at the next one. Now this one, number 3. Okay, so notice the base is the distance from one end to the other end. All right, so you have to make sure that this whole piece right here, I made the little squiggly line so you could see it. That whole thing is the base. All right, so we have this piece plus this piece. Hint, hint, the word plus. That means that you have to add those numbers together to get the whole base. Okay? All right. So I'd add 16 plus, look at my other one, 8 to determine my base. Okay? And my height would be 14. So I'd have 8, okay, 16 plus 8, and add those two numbers together to get my base, and 16 plus 8 is 24. So now I have my base times height divided by 2. All right? And so we have 24 times 14 divided by 2 equals. All right. Does anybody have their calculator out and they can do this? I mean, we could do it by hand, but, in the interest of time, does anyone have their calculator out and they could do this one for us? Anybody? Okay. Anyone have their calculator out? No? So it would be 24 times 14 divided by 2. So 24 times 14 is 336. And then we divide it, 336 divided by 2. And y'all know how some long division, right? So I'll just do it over here. How many groups of 2 are in 336? Here we go. Times 2 go in the 3. 1 time. 1 times 2 is 2. Subtract it out. 1. Bring down my 3. How many groups of 2 are there in 13? 6. 6 times 2 is 12. 13 from 12 is 1. Bring down my 6. How many groups of 2 are there in 16? 8. 8 times 2 is 16. 16 from 16 is 0. Yay me. Total is 168 meters squared. All right, let me check my time because I don't want y'all to miss your Zoom meeting. Okay, it's 2:40. We're doing well. All right, 168 meters squared. Now let's look at the next problem. It is a word problem. All right. Okay, it says, Chauncey is building a storage bench for his son's playroom. The storage bench will fit into a corner against the 2 walls to form a triangle. Chauncey wants to buy a, triangle-shaped cover for the bench. If the storage bench is 2.5 feet along one wall and 4.5 feet along the other wall, how big will the cover have to be to cover the entire bench? Hint, we are solving for area. So they just drew us a little figure. See that? Okay, cool. So let's say, and I'm going to use the what they gave us to draw the figure. So it is 2.5 one side and 4.25 the other side. Hey, boo-boo. All right. So, what you need to do is what? How would we solve that problem? Here, go downstairs to Daddy because I'm teaching the class, okay? All right. Thanks. What would I need to do? How would I figure out the answer to the problem? What do I need to do? What do I need to do with the 2 dimensions that I've been given? Multiply. Remember, we're finding the area of the triangle. So we have to multiply the 2 dimensions together and then divide them by 2. Yay us. So it'd be 2 1/2 times 4 1/4. We multiply together, okay? And then when I get all that together, I'm going to put that over 2. Actually, I'm going to multiply that by 1/2. That'll make it easier to do it that way. And you'll see why in a couple seconds, okay? All right. So remember, we've been doing this all over and over and over again. We've been changing our mixed numbers to improper fractions. We've been doing that over and over again.
My tablet because I want to watch it downstairs.
Ask Daddy. Okay. So what we need to do is we need to multiply our whole number times the denominator. 2 times 2 is 4 plus 1 is 5. So we get 5 halves times, let's multiply our whole number times denominator. 4 times 4 is 16 plus 1 makes 17. All right, times 17 over 4. And I'm going to multiply these 2 numbers together, and then I'm going to multiply them times 1/2. So 5 times 17 is 85. And 2 times 4 is 8. Okay, so I have 85 over 8, and I have to multiply it times 1/2. All right, see that? Because you have your base times height, and then multiply it by 1/2. So we have our base times our height. We multiply those together, and then we multiply it by 1/2. So 85 times 1 is 85. And 8 times 2 is 16. All right. Now, because we are in 6th grade, for another couple weeks, we have to continue with my favorite operation, which is long division. Okay? All right. So, let's do this. How many times the 16 go into 85? So what I do is I round this to 15 because it's easier for me to count by 15 than 16. And for some strange reason, I learned my 15 tables just because it's a number that I use all the time. So go 15, 30, 45, 60, 75. I'll start with 5. All right. And 16 times 5. I'm going to do my little work over here. My little 16 times 5. You know, I like some scratch paper. 6 times 5 is 30. Bring down the 0. Carry the 3. 1 times 5 is 5. Plus 3 is 8. All right. All right. So 16 times 5 is 80. Subtract it out, and I get 5. How many groups? Yeah, and that's it. Okay, so I have 5 and 5/16. Yay, us. All right, I told y'all all day, every day, long division. All day, every day, long division. All right. So our answer is 5 and 5/16. Okay? All right. Let me do my time check because I don't want y'all to be late for the Zoom meeting. Okay, we're doing well. All right. So let's go on to the second page, problem number 5. It says that Darnell and Donovan are both trying to calculate the area of an obtuse triangle. Examine their calculations below. Now, remember, you all discussed obtuse triangles yesterday because I remember I was in Miss Martin Live. And somebody did give you the definition of an obtuse triangle. You all went over what is a right triangle, what is an acute triangle, and what is an obtuse triangle. And when they highlight words or make them dark, it's a little hint that you should pay attention to that because it's important. Okay? All right. So it says Darnell's work. He did area equals 1/2 times 3 inches times 4 inches, and he got 6 inches squared. Donovan's work said 1/2 times 12 inches times 4 inches equals 24 inches squared. Which student calculated the area correctly? Explain why the other student is not correct. Well, let's look back at our drawing and see, can that help us? Now, I'm going to turn mine this way because personally, it's just me. I like my right angle down at the bottom. I like the base down at the bottom. That's just me. I like the base down at the bottom and the height up at the top. Okay? That's just me. I turn it, so that's the way I see it. All right? So let's look at Darnell's work. He said 1/2. Okay, so that was a formula, 1/2 base times height. So you got the 1/2 right. 3 inches for the base and 4 inches for the height. All right? So is Darnell right? Is Darnell right? Is Darnell right? Nope. Darnell is not right. Could y'all tell me why Darnell is not right? Darnell is not right because this is the base of the triangle. This. Remember, okay, that's the base. That's where Darnell got messed up. Yesterday, you all learned that when you determine the length of the base, I must remember not to use the length between the base and the altitude. Okay? This is what Darnell used. He forgot. You're supposed to use the actual base of the shape, and that's where Darnell went wrong. He didn't use the base of the actual triangle. All right, so let's look and see. See right here? This is called a distractor. That's something that they give you to throw you off so you get the problem wrong. It's called a distractor. All right, so let's look at my man Donovan's work. He said 1/2, because that was part of the formula, of base, which is 12, times height, which is 4. All right, and he got 24 inches squared. So let's look. So we know that Donovan is correct, right? Why is Donovan correct? Because because he used the height when calculating the area of an obtuse triangle. I must remember the height is found outside the triangle. I must remember not to use the length between the base and altitude when determining the length of the base. Okay. All right. So remember that, okay? When you're finding the base of the triangle, and we know it's an obtuse because the largest angle is bigger than 90 degrees, and so that's an obtuse triangle. We have to remember that the base is the actual length of the triangle, not the distance between the base and the altitude. And another word for altitude is height. Okay? So y'all can put that in your own words, your explanation. All right? Last problem. Got my man Russell. Russell calculated the area of the triangle below. His work is shown. Although Russell was told his work was correct, he had a hard time explaining why it is correct. Help Russell explain why his calculations are correct. Does anybody want to jump in and explain to me why Russell is correct? So let's look at everything we got. All right. We have 25 centimeters here, 25 centimeters here, 43 centimeters, 24 centimeters here, and 7 centimeters. All right. So he says he has a formula, 1/2 of the base, which is 43 centimeters, times the height, which is 7 centimeters. And he multiplied it out and got 150.5 centimeters squared. So he's right. Why is he right? Why is Russell right? How do we know? Who can explain it to me? We got 2 minutes. And then y'all got to go to your Zoom meeting. All right. So what did he do? He multiplied. He took 1/2, which is a formula, of base times 1/2 BH, or base times height over 2. Okay? So we took the base, which was 43, times the height, which was 7. Yeah. And then he divided by 2. And he got 150.5. Because what happened is Russell remembered that when he's working with an obtuse triangle, the height is listed outside the actual triangle. All right, let me say that again. When you're working with an obtuse triangle, the height is found outside of the triangle. So we had the height of 7 centimeters and the base of 43 centimeters, and he multiplied those two together, and he divided by 2, and he got the right answer. Okay, well, y'all, that was absolutely positively fabulous. And does anyone have any last minute questions? Because I know you all have your Zoom meeting at 3 o'clock. So I want to make sure everybody has a chance, go to the bathroom, do everything you need to do, attend to all your personal needs before, and then that way you can jump in the meeting at 3 o'clock. So thank y'all so much for coming. And don't forget, I will see you all on Monday because I am in Ms. Martin's Live. So I'll be in there Monday at 10. All right. So have a wonderful weekend. Stay safe. And I will see y'all on Monday. Bye.